Hey everyone, Nick Dearburtis here, teaching you financial modeling. Today we're going to be looking at an example of adding sensitivity analysis to an existing model. This is part of our segment on exploring the parameter space. So we left off last time having done an introduction on sensitivity analysis in Python and looked at some of the different outputs we were going to produce and approaches we could use. And now we're coming to actually apply that to our existing dynamic salary retirement model. So let's go ahead and jump over to that model so we can build this extension to the model out. And you can find the completed extension from this exercise on the course site. And I would recommend that you take a look at that completed example as you go to work the lab exercise for this and to add sensitivity analysis to your own models in the future. Uh, so we're going to add sensitivity analysis. So we can go ahead and make that as an additional section down here, sensitivity analysis. And you would want to put a description of what you're going to be analyzing, why, what are the takeaways. But I'm going to leave that out for now for sake of time. And I know that I'm going to need to use the sensitivity analyzer, so I'm going to go ahead and add that import up here from sensitivity import sensitivity analyzer. Sometimes, yep, if you tab complete, sometimes it will tab complete it for you, so that worked out for me. Then I'm going to restart kernel and run all cells so that we have everything from the model defined and then can just work with it below for the sensitivity analysis. Now we're ready to start building out the sensitivity analysis, but one thing that you may notice about my existing model function years to retirement is when I call it, it prints out output. And when we go to do sensitivity analysis, basically this function is going to get run a bunch of times with different inputs. And we're going to see that doing that without any changes, we would get this whole print output for as many times as we're running the model. And we could be running the model thousands of times. So we don't want to get thousands of copies of this print output for the different output cases. We're already going to be storing the main output that we want to look at separately. So before we can even add the sensitivity analysis, I'm going to go back and make a modification to the existing model to make it optional whether it prints out the results. So we've already talked about optional arguments before. We can add an optional argument here. Print output equals false. So it defaults to it should not print any output. And now I'm just going to go to each of the print statements and say if print output, then it's going to print. Otherwise, it's not going to print. So I'm just going to do the same thing with each of these. And now I'm going to rerun that to redefine that function. And now you'll see that when I run this, I don't get any output there. I just have the final answer stored in the variable. Well, with this usage, we do actually want to print the output. So I'm going to put print output equals true. And now we're back to exactly what we had before for the original model. But we're also able to call the model without producing all that print output, which is what we're going to need to go into sensitivity analysis. So now the model is ready for us to go and add sensitivity analysis. So now we want to use the sensitivity analyzer. But there's one other thing we have to do to prepare the model function before we can pass it to the sensitivity analyzer. So the sensitivity analyzer is expecting to be able to pass each argument separately to the function. But the way that we structure our models is we use a data class. We pass only a single data class into the function and not each of the separate arguments. So we have to create a function that will take the separate arguments, construct the data class from those arguments, and then pass the data class into the function and return the result of that function, so that it's basically a wrapper around the model function, which allows it to take the inputs separately rather than as a data class. So we can write that function. So I'm going to call that years to retirement separate args. And I'll come back to the arguments section in a moment. And then what we're going to do is we're going to create an instance of model inputs. I'll also come back to this in a moment. And then we're going to return calling the original years to retirement function on that data. Now, what we're going to do for the arguments themselves, there's actually a shortcut in Python which just says, let me take any number of keyword arguments, keyword being where you say like starting salary equals 10,000 or promo raise equals 5%. So it can take any number of those, and then it will just take all those and be able to pass them into the model inputs. So that shortcut here is star star on a variable name, and the convention is to do star star quargs. So that just says any number of keyword arguments, it's going to take those and it's going to put them into a dictionary. Coming into the function, you have a quargs dictionary. So let me just print that to make that clear. And then doing it again here, it spreads it back out into the keyword arguments. So this will take the keyword arguments and collect them into a dictionary, and then this will take that dictionary and spread it back out into the keyword arguments. So not expecting everyone to fully understand what's going on there. You don't have to understand it. You can just copy my code snippet and change out the model function and the name of the function, and you'll be good to go to use the sensitivity analyzer. So to show what this is doing, I'm going to call this and I'm going to say starting salary equals 10,000. And you'll see from the print output that it prints out the starting salary in a dictionary with this as the value, and you can add other arguments here. 30% promotion raise, we can see that also comes into the dictionary, and then we ultimately get the result from that. So this is our wrapper for the function, which then is able to call the model and return the result. So now that we have that working, then we can go on to the next step, which is to actually use the sensitivity analyzer. But something weird is going on here, because no matter what inputs I'm putting, I'm still getting 28 years to retirement. Oh yeah, I see the mistake here. Here, and a lot of people may make these mistakes in their own models. Here, data was being passed to the function, but here I used model data, so it wasn't actually able to pick up the data which is being passed to the function. It was just using the overall model data each time. And so I'm going to make sure that that matches up with the function argument. And now I'm going to restart and run this thing all again. And now we should see a number other than 28 come up here, hopefully. Yeah, there we go. Now it's actually working. If you make $1 million off the bat, then you'd be able to retire in only 5 years. Okay. And then back without passing any arguments, we're back to 28. So it looks like this is all working properly now. So next, we want to create that dictionary of the inputs that we want to change around. So I'm going to start it out simple and we'll expand on this. So sensitivity values. So let me just look at starting salary. Let me look at, as low as 40,000 or as high as 120,000. And then let's look at the interest rate. And let's look at a 3% rate and a 10% rate. So then we have everything that we need to go ahead and run the sensitivity analyzer. So then I'm going to create an instance of the sensitivity analyzer. I'm going to pass it the sensitivity values, and I'm going to pass it the model function, the one that takes the separate arguments. So then we see that it ran 4 different input cases here, 2 times 2, and now we can look at the results. So we can look at the full result data frame there, each of the pairwise combinations and the years to retirement. And we can create the resulting hexbin plot. And then we can create the style data frames. Here, just a single data frame for now. So that's pretty much what you would want to be seeing from sensitivity analysis, as well as, some description of the results that you found at the end. But there's a fair amount we can do here to clean things up and to make them more comprehensive. So first thing is we can pass some additional options to sensitivity analyzer to clean up the output. So some of those additional options would be that we want to label the result. So we can do result name equals years to retirement, because we can see right now it's just coming as result, 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 but we put years to retirement here as result name, and then we get years to retirement, years to retirement, years to retirement. And then we'll notice that right now it's highlighting the high years to retirement as green and the low as red. That's the opposite of what we want. So we want to reverse the colors. Reverse colors equals true. And then with that, we will see that now it's showing red for the high years to retirement. That's bad. We want to retire sooner. You'll notice that this grid is very sparse. So I'm going to pass a grid size of 3. And then you'll see now, this will get more filled out as we add more inputs here in a moment, but I think this makes more sense for these data. And the other thing that we'll want to do is add some labels as well. And it has to match up, the keys match up again with the input names, and then the values would be how you want it to look in the output. So interest rate, interest rate. And then we can pass labels equals labels. And we run these again. Now we can see in all the output that we're now getting the labels as well. So it's starting to look clean. And the last thing we can do is add a number format. So years to retirement, not a currency. We don't want a dollar sign. And we can just have 0 decimal places. So then we'll see now in the style data frames that we have no decimal places on the output. So that looks good as far as the formatting options for the output. Now let's look at some more values of the inputs and look at more inputs. So it can get tedious to type out all the different values that you might want to look at. So that's why I like to use list comprehensions to write out the outputs. So if we want to look at salaries in the range of, say, 40,000 to 70,000, what we can do is we can just do a simple for I in range loop and multiply the result by 10,000. You know, without the 10,000, it would be 4, 5, 6, 7. Then we just multiply it by 10,000. And then we have that range of salaries. So I'm going to put that in here as the starting salary. Then for interest rate, here we want to look at percentages. So let's divide by 100 and let's look from 3 to 6%. I'm going to take that and put that into the interest rate. And let's look at the other inputs as well. So promos every n years. And all of these things should be matching up with the attributes on the model data. So promos every n years. Let's look at in the range of how about from 4 to 7 years? So I'll put that there for promos every n years. Let's add cost of living raise. And cost of living raise, that is another percentage we can divide by 100. And let's go from a 1% to a 3%. So I'm going to put that there. And we can add the promotion raise, promo raise. And for that one, here we can look in increments of 5%. Let's look from 10% to 20% in 5% increments. So let's keep that divided by 100 since it's a percentage. And we're going to go from 10 up to 25. But let's go in 5 steps. So this is 10, 15, 20%. Of course, you can write these out manually if you want, just writing those numbers in. But I like using the list comprehensions because it's also easy to go and adjust these ranges as well. Let's see. So let's also add the savings rate. Savings rate. And for savings rate, let's go up to from 10 to 40% in 10% increments. So that would be this, and 20, 30%. And let's look at the desired cash. So for desired cash, let's look at from $1 million to $2.5 million in 500,000 increments. So that's going to be 10 to 26 by increments of 5 and multiplying by 100,000. So that looks correct. Now we can take that and put that in there as well. So then we have all these different values of the inputs that we want to look at. Let's add their labels as well. So promos every n years. Promos every n years. Let's do the cost of living raise. Cost of living raise. let's do the promo raise, promotion raise. I got interest rate already. Add savings rate, and add desired cash. Okay. Now we've got a bunch of different values of all these different inputs. We've got all the labels. We had all our options from before to make it look good. Let's go ahead and run this. And now you'll see we have a lot more inputs that we're looking at. We have 6,900 different cases. And now it actually takes some substantial time to run the model. And we see that progress bar go by as it's running all these different input cases. Now it's done. We look at this data frame. Um, we it's going to be having a lot more rows in it this time. And we should similarly see additional plots and styled data frames, all of this coming together. So there's a big advantage over Excel in here in that you can pass as many possible inputs as you want. You're not limited to just looking at two at once. And it's going to be able to generate a lot of different results for you. So now we have these 6,900 different runs of the model in a data frame. And we've got all these different combinations of the inputs in these plots. So we can take any pair that we want to look at. Here it's all about the promotions, promotional raise, promotions every n years. As you get quicker promotions, we start to hit, slower promotions, then we get to longer years to retirement, up to 40 over here. And as we get higher promotion raises, then we get shorter years to retirement. But we can see in the range of inputs that we're looking at, it's not a very huge impact on the years to retirement. So then you have the same information over here in the style data frames. So you can really pick whichever one of the two you like better for showing the results. You don't have to show both like I'm doing here. And it would be good to, at the end, just put a description of your findings, some of the notable things from the sensitivity analysis to kind of wrap everything together. So that's adding sensitivity analysis to an existing model in Python using the sensitivity package. So that concludes our segment on exploring the parameter space. We will examine a couple other techniques which explore the parameter space in the future lectures as well. So thanks for listening, and I'll see you next time.